Uncontrolled Node-RED deployments introduce unacceptable risk in industrial environments. A failed flow update requires immediate, reliable rollback, which the standard deployment button does not provide. We bypass the Node-RED project feature, which often complicates CI/CD integration, and focus on direct Git control of the user directory. Locate your Node-RED user directory, typically ./node-red or /data in Docker containers. This directory contains the critical flows_star.json files and the settings.js configuration. Before initialization, ensure Git is installed and accessible within the Node-RED host environment. This approach guarantees atomic versioning of the entire configuration state, not just the flow logic. Navigate directly into the Node-RED user directory. Execute git init to establish the local repository. The core files requiring tracking are the flow definitions. These are usually named flows.json or flows_hostname.json depending on your setup. Crucially, we must exclude sensitive data immediately. Create the .gitignore file in the root of this directory. This file prevents accidental exposure of credentials and environment-specific settings. We rely on the package.json file for dependency management, ensuring a clean, portable repository. The .gitignore file must explicitly list settings.js if it contains environment-specific paths or secrets. Always ignore context.json and context.json.back, as these store runtime state and are not part of the deployable configuration. The most critical exclusion is the credentials file, typically flows_star.json.cred. Committing credentials, even encrypted ones, violates security policy and portability standards. Also exclude the node modules folder entirely. We rely on the package.json file for dependency management, ensuring a clean, portable repository. Commit the .gitignore file first using git add.gitignore, and then git commit-m initial ignore rules.
Now track the flow definition files. Use git add flows.json or the specific file name matching your environment. If you use subflows or configuration notes, these definitions reside within the main flow file. Node-RED stores the entire canvas state in this single file, making versioning straightforward, but requiring careful conflict resolution later. Execute the initial commit. Git commit-m baseline production flow version 1.0. Verify the repository status using git status. Only the flow file, the settings file of tracked, and the .ignore file should appear. Do not track log files or temporary files generated during runtime. To enable collaboration and centralized backup, connect the local repository to a remote origin. Use SSH keys for secure authentication, avoiding password prompts during automated pushes. Generate the key pair on the Node-RED host if necessary, and register the public key with your Git service provider, such as GitLab or GitHub. Add the remote origin using the command git remote add origin git at your server/repo/node-red-flows.git. Verify the connection with git remote-v. Finally, push the baseline configuration to the remote branch, typically main, using git push-u origin main. This establishes the single source of truth for the production flow. The controlled deployment workflow involves 4 steps after flow modification in the Node-RED editor. First, click the standard Node-RED deploy button to save the changes to the local flows.json file. Second, stage the changes. Git add flows.json. Third, create a descriptive commit message detailing the functional change. For example, git commit-m feature added modbus : retry logic. Fourth, push the committed changes to the remote repository. Git push origin main. This sequence ensures that the running production state is always mirrored exactly by the latest commit hash in the remote repository, providing an auditable history.
If a deployment introduces critical errors, immediate rollback is mandatory. First, identify the last known stable commit hash using gitlog-online. Execute the hard reset command, git reset-hard stable commit hash. This action overwrites the local flows.json file with the content from the stable version. Node-RED does not automatically detect this file change while running. Therefore, the Node-RED service must be restarted immediately after the reset to load the reverted flow definition. Use systemctl restart Node-RED or the equivalent Docker restart command. This process guarantees the production environment reverts to a verified state within seconds. Node-RED's single flow file structure makes merge conflicts frequent in multi-developer environments. Before any local modification or push, developers must execute git pull origin main to fetch and merge remote changes. If a conflict arises, Git marks the conflicting sections within flows.json. Manual resolution is required, carefully selecting which JSON object definitions to keep.
Since flow definitions are complex JSON structures, use a specialized merge tool like VS Code's integrated diff viewer rather than manual text editing to prevent syntax errors. After resolution, stage the merged file and commit the merge result before pushing. Manual Git operations are sufficient for small deployments, but CI/CD integration is necessary for scalable industrial systems. Configure a webhook in your Git repository manager to trigger a pipeline upon successful push to the main branch. The pipeline job should execute 3 steps. First, pull the latest commit onto the staging or production server. Second, validate the flow file syntax using a linting tool. Third, restart the Node-RED service on the target machine. This automation eliminates human error during deployment and ensures that only verified committed code reaches production. Consider using Git tags to mark specific production releases, enabling precise version tracking across the entire industrial control system.